Hey class. Today I'm going to go over all the final review for your class. Yeah, hopefully it goes well and it works out. If I make any mistakes, just tell me in class. And I'm also going to show you along with this the calculator, how it can help you. So I'll switch back and forth to that. Otherwise, let's get it started. All right. Okay, so let's start off with the first thing here. The test should be in order and should cover everything. I think everything is attached to this. If there's an error with this, like if something didn't show up, just tell me later and I'll fix it or check it out or something like that, or do it in class. All right, rewrite the equation in exponential form. So in this case, when you move the base of a log, and I'm going to go quickly through these because not only we've learned this in the past, but you can always stop and record your, go back. So if you ever need to check your work, you could just always go back and work it out. So log base 3, we're going to move it to the other side, to the fourth power. So what happens is when it becomes a base of a log, it becomes a base of an exponent. So 3 to the fourth power. So when rewriting an exponential form, this is an exponential form. That's how your multiple choice is going to look like. Same here. The base of an exponent becomes the base of a log. So this becomes negative 2 equals log with a base 5, 1 over 25. Okay. Over here, log 1000. In this case, you could think of it as log base 10, 1000, which I could rewrite equals x. And I can rewrite that as 1000 equals 10 to the x power. So I should see 10 to what power gives me 1000? That should be 3. So x must be 3. But again, I'm going to show you how to use the calculator. Here, we could literally just click the log button and then 10,000, 1, 2, 3. Press enter, and you see it's 3. So you can use the calculator to your advantage, okay? Number 4, y equals log base 6, 3x. We're going to find the inverse. So the first thing I do is swap the position. X equals log base 6, 3y. Then I'm going to move the log base 6 to the other side. So I'm going to move the log base 6 to the other side. So it's going to become, so it's going to become 6 to the x power, 3y, divided by 3 on both sides. The 6 cannot be divided by the 3 because this is 6 to the x power. So it's not the same as a normal number. So we have to leave it like this. Trust me, I know if I were, I know I made the final. I'm going to put 2x equals y as a fake option. Don't fall for it. It should be 6x over 3. Here, when you move an e over to the other side, first let's swap the positions. So e 2y equals x. So I'm going to move the base e to the other side. When I do that, it does a special log. We call it ln. So ln x, then divide both sides by 2. So y equals ln x also 2. Here, expand the logs. ln 12w, when you expand a log, when they're multiplied, they become addition. So ln 12 plus ln w. That's it. You just expand it like that. Here, log 10, log x, log y. When you divide, you subtract. So this is going to be log 10 plus log x minus log y. Here, we're going to expand this to ln x to the third plus ln y to the fifth minus ln a to the square root. But exponents can be moved to the front. So this 3 is going to be moved to the front. This 5 is going to be moved to the front. And this a to the square root is the same as a to the half power. So I'm going to move the half power to the front. So that's going to become 3 ln x plus 5 ln y minus a half ln a. Okay? And then if it's a multiple choice, it probably will look like ln a over 2, just to show that. But both are good. On the multiple choice, I think it will be ln a over 2, or something along those lines. Again, when I say it's in the multiple choice, it's not that they're the exact same questions, but a question that has this kind of system will show up like that. Okay, condense the log, so the reverse of expand. So the 3 goes on top. So log x to the third, y to the 6, divided by a to the second, because subtraction means division. Keep in mind, it will only be log 1. There will only be one log. I remember when we were grading this and how I made the test, I'm going to put a fake one like this because people made that mistake before. There's only one log, okay? Here, ln 9 to the half power is the same thing as ln square root of 9. So the ln square root of 9 is the ln of 3. So ln 3 over 10. Here, solve for x. So 4 to what power gives you 1 over 16? Now I'm going to show you by mentally. You should know, hey, this 16 is the same as 4 to the negative 2 power. So x must be equal negative 2. How is it 2 to the negative 2 power? I'll let you think on that. But you might be like, okay, I don't know why. So what can I do? Instead, 4x equals 1 over 16. You could move the base 4 to the other side. So x equals log base 4, 1 over 16. Then you could type that into your calculator. So I can pull out the calculator. But the problem is I don't have a base 4 log in the calculator, right? There's no base 4. There's only log and ln. So what I'm going to do is rewrite this as log, the normal size number, which is 1 over 16 is on top, over log the base of the number, which is 4. So I'm going to do log, I already had a parenthesis, log 1 divided by 16. I'm going to close the parentheses. If you don't close the parentheses, you're going to get the wrong answer. Log 4. And that's going to become negative 2, which is what I said earlier. Okay? Number 12, 3 and 9, they don't match. If they match, we could cross this out. But what we could do here is rewrite this as 3x plus 1 equals 3 to the second power x minus 1. Exponents multiply to exponents. So this is going to be 2x minus 2. And because these both match, the 3 and 3, we could cross these both out. And it will become 3x plus 1 equals 2x minus 2. Subtract 2x on both sides, x. Subtract 1 on both sides, negative 3. X equals negative 3. And remember, since it's multiple choice, you can see that your option is negative 3, and you could plug it back into the equation and see if it's true. So negative 3 to the negative 9 minus plus 1 is negative 8. So let's check that actually. 3 to the power of, what would it be? 3 times negative 3 plus 1. That would be this number. Now you're like, how am I supposed to know what that number is? I don't really care what that number is. What I really care about, what is this? X minus 1? Is that if it's matching, so 9 to the power of negative 3 minus 1. So that the fact that these two match must mean they're equal to each other at negative 3. So you can always check your answer and use the calculator to your advantage on that one. Next one, e to the 3x equals e to the x minus 12. Because they match on both the top and the bottom, or they match both bases, you could just cross those bases out. So it's going to be 3x equals x minus 12. A little bit of algebra, x equals negative 6. Negative 4. Oops, negative. Oh wait, no, negative 6. I was right. Because 2x and then divided by 2. So negative 4. Negative 6. Again, plug that in if you want to check it out. Here, log base x equals 4. Remember, if you don't see 1, it's a divisible 10 for log. So I got to move it to the other side. So x equals 10 to the 4th power. I don't think anyone realized this during the test, but I gave you that question before, just in reverse, which is 1, 2, 3, 4. So 4 zeros, so 10,000. I gave you that question in the past. Oh, no, I gave you a different question, I guess. No, I didn't. I take back the statement. Don't worry what I said. This one, log base 2, because both of the log bases match, you could cross that out. So it becomes 3x plus 10 equals 5x minus 6. A little bit of algebra is going to be 8 equals x. Over here, before we could cross out the logs here, we have to make it only one log on each side. So before I could do that, I'm going to have to condense these. So 4 plus 3x is 4 times 3x. So this is going to be log 12x equals log 5x plus 14. And trust me, I'm going to put the fake answer as if you did 4 plus 3x equals 5x plus 14. I'm going to put the fake answer there on the multiple choice, so make sure you don't fall for that. Cross out the logs on both sides. So I get 12x equals 5x plus 14. A little bit of algebra, x equals 2. All right, next one is the polynomial ones. Let's zoom in so I have more, shows up better. So here, when you have polynomials, anything that matches, you could cross out. So x plus 3 cross out. X minus 5, x plus 5 do not match, so I cannot cross those out. But 12 and 9, I reduce to 4 and 3. So my final answer here is 4x minus 5 over 3x plus 5. Over here, x squared minus 4. They don't match, but if I were to factor the top and bottom separately, so this is x plus 2, x minus 2. And over here, it's going to be x plus 7, x plus 2. Because the x plus 2's match, I could cross them out. So x minus 2 over x plus 7 is my final answer. And again, I'm going to go fast because not only have we done this in the past, but as long as you get the concept, you could take your own time figuring it out. I need to factor this, so what I'm going to do is rewrite it as x squared plus 8x plus 15. I'm going to slide and divide if you don't forget that. So you're going to bring that over here. What multiplies to 15? That adds to 8. X plus 5, x plus 3. Then I'm going to divide both of them by 3. Which means my answers are going to be 3x plus 5, and then x plus 1. Over here, it is x plus 1 squared. Because I have x plus 1 here, I could cross out, and I could reduce it by 1 down here. So it's going to be 3x plus 5 over x plus 1. Next one. Let's first combine the top and the bottom before we do such subtraction. So 48 times nothing is 48. 5x times x to the third is x to the 8th. Remember, when you multiply exponents, you add the exponents. Y to the third times y to the first is y to the fourth. Y to the fourth times y to the second is y to the sixth. There's nothing happening to the x, and there's nothing happening to the 6. Now I'm going to reduce each one separately. So 48 divided by 6 is 8. X8 divided by x second, you subtract that, so x to the 6. And y to the fourth minus y to the 6 would be y to the negative 2, but we're going to move that to the bottom, so it's going to be y to the second, because we don't want a y to the negative power. So we're going to move that to the bottom. So this will be the final answer. It won't show y negative 2. It will be over y2. Here, we could combine it into one thing, or we could cross out before we even combine. So see, I see both x plus 5s. I'm going to cross that out. the 4 and the 2 I could cross out to 1 and 2. And the x squared and x, this is x to the 1, x to the second. I could cross out one of these and cross out the second, so it would be x to the 1 left over, or I subtract it. You could think of it like that. Which means it's going to be 2x plus 1 all over x. Even though the x plus 1 and x both have x's, they're not exactly the same. The plus 1 is a unit pair, like they're to go together. So you cannot cancel out the x's. Here in this one, when I have a whole number like this, I'll just put it over 1. I have to factor everything, so I'll do top left first, which is x minus 5, x plus 2. On the bottom left, it'll be x minus 5. Oh, wait, what is this one? Negative 15. Yeah. X plus 3, my bad. X plus 3. There you go. Times 21 and 10 is going to be x plus 7, x plus 3, all over 1. All right, cross out anything you can cross out. I see x plus 3 is cross out. And I see x minus 7, so I could cross out. So my final answer is x plus 2, x plus 7. Okay, number 7. When you see a division, you got to remember you got to flip the symbol. You got to flip this one, the reciprocal. So 5x squared y to the 3rd over x to the 7th times, now I'm going to flip this over, y to the 3rd, 30xy to the 4th. When I deal with a lot of little things, I like to combine them first on top and bottom before I simplify. So 5 on top, x second, y to the 6th, over 30 x to the 8th, y to the 4th. Then we'll reduce. 5 over 30 is 1 over 6. X to the 2nd divided by x to the 8th. There's 6 x's on the bottom left over. Y to the 6th divided by y to the 4. There's 2 y's on top. And the final one would not have the little 1 here, so it would look like this. So your multiple choice answer would look like that. Next one. Again, because it's division, we're going to flip this. X plus 3, x minus 2, times x over, I didn't make it one big fraction line, x minus 2 times x over x, x plus 1, x plus 3. In this case, we have an x plus 3 on top and bottom. We have an x on top and bottom. So all we have left over is x minus 2, x plus 1. Division means I got to flip again. I'm going to factor this at the same time to speed it up because I'll be here for a while anyway. So factor this top left one, which is x minus 2, x plus 1. Factor out this bottom one, which is x plus 5, x minus 1. I'm going to flip this and factor. On the top over here is going to take out a 5 and then leave with x plus 5. On the bottom is just x minus 2. Okay. With this in mind, x minus 2 crosses out, x plus 5 crosses out, x plus 1 and x minus 1 are different things, so I cannot cross them out. So it's 5, x plus 1 over x minus 1. This one, when we subtract, we need to have the same base. They already have the same base, so we're very happy. So it's 9 minus 2x over x plus 1. Check if you could simplify. I can't factor anything on top and bottom. Nothing matches, so that's equal. Since they have the same base, we can subtract straight through. And 9 and 2x are not even like terms, so you can't even subtract those. Here, they're not the same terms, so I'm going to need to multiply both sides by something. Here, I want to add a 5, so I'm going to multiply this side by 5 over 5. And here, it needs an x, so I'm going to multiply this by x over x. So this will become 12x over 5x plus 35 over 5x. Since they have the same bottom now, or the same denominator, we could add them. 12x plus 35 equals 5x. Circle it, we're done. You can see if you can factor out anything on top, but this is 3 and 7, this is 4 and 3. No, there's nothing we can do. Here, we need a match, but we don't want to just multiply to both sides. We want to see what's missing between these. So this has a 3xx. Let me use the thin line. So on the left side, it has a 3, an x, and an x. While on this side, it has a 4 and an x. So in terms of things they already have in common, they have an x in common already, which means I only multiply by what's different between them. So this side only needs a 3x on both sides. Well, this side needs I don't even know what green I used over here, a 4 on both sides. So this is going to become 4 times 8, 8, 16, 32 over 12x squared minus 5 times 3x is 15x over 12x squared. So 32 minus 15x over 12x squared. Always double check if you could factor something out. 32 is a number that can't be factored out with 15, so we're good. Here, x plus 4 is its own package deal. X plus 7 is its own package deal. So there's nothing to say about do they have anything in common. So this needs an x plus 4. And this needs an x plus 6 on both sides. So over here, you're going to get 3x plus 18, I distribute, minus x plus 4 all over x plus 4, x plus 6. I don't want to combine them really. So then 3x minus x is 2x. 18 minus 4 is plus 14 equals x plus 4, x plus 6. On the top, I could factor out a 2. So 2x plus 7 over x plus 4, x plus 6. But even though I factored out that 2, it doesn't make a difference. So this is your final answer. I can't cross out anything, so nothing gets crossed out. All right, solve and make sure to remove any extraneous solutions. You're going to bet that in the multiple choice, I'll leave the extraneous solution to trick you. So when you have an equal fractions here, you could just do a cross multiplication. So the cross multiplication is 4x plus 24. I'm just distributing right away. Equals 10x. A little bit of algebra. 4 equals x. Now, what do I mean by extraneous solution? You always just plug it into the bottom again. Does it cause a 0? This would cause an 8. This would cause a 10. So no zeros, no problem. Here, again, cross multiply. X minus 3 times x plus 2. I'm going to do this quickly. X squared minus x plus 6, or minus 6. I did 2 quickly, I made a mistake, minus 6, equals x times x plus 5, which is x squared plus 5x. We're going to set it equal, let's see, we're going to subtract the x squared on both sides. That cancels out the x squareds. So it's negative x minus 6 equals 5x. Quick algebra, negative 1 equals x. Check. If you plug it in, this would be a 4, this would be a 1. Yeah, no problem. It doesn't cause a 0 on the bottom. Here, we need to make the common denominator before we add this. So I want something over here, which means this middle one definitely needs a 2 over 2, or a x over x, I mean. So it's going to be 4 plus 2x over x equals 10 over x. Wait a second, since the bottoms exactly match, I don't need to cross multiply. I could just cross them out. And this only works because they match exactly. Which means it's going to be 4 plus 2x equals 10. A little bit of algebra is going to be x equals 3. Again, check. Does this cause it to be a 0 anywhere? No. So it's okay. Okay, my thing is jammed. All right, here we go. Next one, 17. Yeah, 17. I need this to match. Remember, it's 3x. It is 3x. 6, 3x. Since they all in common have a 3, I can reduce this to 1, 2, 1. So this guy is missing a 2, so he needs a 2 over 2. This guy's missing an x, so he's missing an x. This guy's missing a 2, so it's going to be a 2 over 2. So 2 times 2 is 4. 1 times x is x, so plus x over 6x equals 2 times 4 is 8 over 6x. Wait a second, we could cross these out. So it's 4 plus x equals 8. Second line arrow. A little bit of algebra, x equals 4. Check again. This causes 12. This causes 12. No extraneous solution. Remember, if it causes a 0 on the bottom, it will be an extraneous solution. All right, this one I will give you the equations for. So find the first 6 terms. Actually, this is just find the first 6 terms. So I just plug in 1, 2, 3, 4, 5, and 6 into the equation. Now I could just plug this in. Negative 1 times 3, or negative 3 times 1 is negative 3. And 2 times negative 3 is negative 6, negative 9, and negative 12, negative 15, negative 18. You could do that. You could plug it in. Or you could have your calculator do it for you. Where I could take the equation here, which is negative 3n, go to my calculator. I could go y equals and put negative 3, I'll put x instead of n. And then I pull out the table. So I click second graph to get the table. Here, if you notice, wait a second, 1 is negative 3, 2 is negative 6, 3 is negative 9, 4 is negative 12. I could just plug it in here for the answers. So I could use my calculator to the advantage. Again, I could do the same thing. 1, 2, 3, 4, 5, 6. Which means it's 2x minus 1. Go to y equals 2x minus 1. Second table will give me a table. 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11. What about this one, which would take more work? 1, 2, 3, 4, 5, 6. Wait a second, I could just do y equals x squared. Is it minus x or plus x? Minus x. Second table, again, I could just look at this. 0, 2, 6, 12, 20. 6, 12, 20, 30. So I could use that to my advantage. Why don't I use the calculator? Is there any more down here? Oh. Tell if it's arithmetic, geometric, or neither. So you have to check if the pattern is not only consistent, but the same thing. So this is a plus 3. This is a plus 4. This is a plus 4. This is a plus 3. So this is not consistent, even though it's repeated action. So this is neither. It's not consistent. Oh, this is plus 3 over here, but this is a plus 4. This is a plus 3. So because there's no consistency there. Here, I remember this one. This one, you could kind of see 10 over 4 is 5 over 2. 5 over 2. This is not 5 over 2. This is 3 over 2. So because that's not consistent, it's neither. Plus 2, plus 2, plus 2. That's consistently adding, so that's arithmetic. And if it's consistently multiplying or dividing, it's geometric. Describe the pattern and give the next term. So this is plus 1, plus 2, plus 3, plus 4. We could figure out the pattern, plus 5. So the next pattern must be plus 6, which means it must be 23. Here, the top and bottom are separate. So 10, 11, 12. So this is plus 1 on top. Well, this is minus 1 on the bottom. So the next one is going to be 14 over 5. Again, I'm not asking you to make the equation. I'm just asking you for the pattern. Now, use the rule. Now, the rule is an equation. I will give you this equation. AN equals A1 plus D n minus 1. So when we're going to make the equation, we're going to fill it out. So A1 is your first term. So your first term here is 7. So 7 plus D is your pattern. So what's happening each time? Each time I'm minusing 3. So it's going to be not plus 3. Okay, so negative 3. So minus 3. N minus 1 equals AN. Now the thing is, the answer is not going to look like this. What we're going to do is simplify it. So 7, distribute the negative 3 to here and here. So negative 3n plus 3. So that's going to be 10 minus 3n equals AN. So that's how it's going to look like in the multiple choice. This is a correct answer, by the way, but since it's multiple choice, this is how it's going to look like. Over here, a to the 10 power. So a to the 10 power. So I'm going to be, not to the 10th power, I'm sorry, the 10th term. So I want the 10th term in this pattern. So what I could do is just plug in 10 into the equation I found. 10 minus 3 times 10. The answer is going to be negative 20. So the 10th term is negative 20. You could also, if you have the equation, 10 minus 3n. So you could just do 10 minus 3 to the x. Yeah. If you put second table, first off, you should see 1 is 4, 2 is 7, 3 is 1. So your pattern matches. And then I can scroll down all the way to 10, see it's negative 20. Okay? Here, they give you the pattern and the step, the first one. So I already have this thing. So it's going to be AN equals the first number, 5. You could scroll up if you're review or go backwards in the video if you need the equation. Plus 12 n minus 1. So 5 plus 12 n minus 12. So negative 7 plus 12 n would be your equation. Plug in a 10 in this. 120 plus negative 7 equals 113. This one, A1 is negative 15, A11 is 35, so I need a pattern between this. Well, since I know A11, what I could do is A11, which by the way is 35, equals A1, which I know is 15, negative 15, plus the D value, which I don't know what that is yet. But n, since I use 11, my n is going to be 11 minus 1. So 35 minus 15 plus 11 minus 1 is 10, so 10d. equals. Plus 15 on both sides, 50 equals 10d. Divided by 10 on both sides, 5 equals d. So I found the pattern is 5. So I can make the equation an equals negative 15 plus 5 n minus 1. Distribute the 5. Negative 15 plus 5n minus 5. Combine like terms. Negative 20 plus 5n equals an. So that's the rule, and I assume I asked for step 10 or something. The equation was, what was it, negative 20? So negative 20 plus 5 times 10, so that's 50. So that is going to be 30. All right, the rule for the geometric sequence. The rule for the geometric sequence is an equals a1 times r. R is the pattern for geometric sequence, n minus 1. So with that in mind, let's figure out the rule. The first step is 3. So an equals 3 times the pattern here is times 4, times 4, times 4. So the pattern is 4 n to minus 1 power. Usually we sometimes put parentheses here just to indicate that n minus 1 is only on the 4. Okay, so then we just do 3 times 4 to the 6th power minus 1. 3 to the 4 times the 5th power. I don't know off that by hand, so I'm just going to go to my calculator. 3 times 4 to the power of 5. 3,072. Our next one. A1 is 3, R is 2, so it's even easier. 3 times 2 to the n minus 1 equals an. Luckily for this one, we don't have to simplify. Then plug in a 6. 3 times 2 to the 5th power, because 6 minus 1 is 5. 2 to the 5th power is 32. 32 times 3 is 96. Here, we need to figure out what the pattern is. Well, I have A3. So A3, by the way, which is 250, equals A1, 10, times R, which I don't know what R is, to the power of 3 minus 1, because it's A3. So I'm going to divide 10 on both. Well, I'm going to do this. 250 equals 10R to the 2nd power, divided by 10 on both sides. 25 equals R to the 2nd power. Square root both sides. 5 equals R. Now, I just realized it should technically be plus or minus 5. For these questions, assume it's just a positive one. Because in this equation, since I gave you a third one, you don't know if it's like 10 times 5 would be 50, and then times 5 would be 250, or 10 times negative 5 would be negative 50, times negative 50, a negative 5 again would be again positive 250. So that's why it's plus or minus 5. For the multiple choice, there will only be one correct answer. So either I leave positive 5 or negative 5. Okay? I want to put plus or minus 5. That's not necessarily true. It's either one or the other. Okay, so we plug it into equation. An equals, R is 5 by the way, so 10 times 5 to the 6 minus 1 power. So 10 times 5 to the 5th power, because 6 minus 1 is 5. 31250. So 31250. Okay, this one we're going to find the sums of the series. So when we start from 3 to 7, we need to find it at term 3, term 4, term 5, term 6, and term 7. So I got to plug in 3 into the equation. So 3 squared, 9 minus 3 is 6. 4 squared, 16 minus 3 is 13. 5 squared is 25 minus 3 is 22. 6 squared, 36 minus 3 is 33. 7 squared, 49 minus 3 is 46. So with that in mind, I just add this all up. 6, 12, 14, 20, carry the 1, carry the 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait a second, 10, 12, yeah. So this ends up being 120. Again, you can use your calculator to just confirm that. Here, 1 through 13. So either you're going to go 1, 2, 3, 4, yada yada to 13. Or you can use your calculator to your advantage. Now in here, let me just make sure I actually remember how to do it. Let me just make sure. Is it? All right. So depending on how good your calculator is, you could use a summation machine. Now, if you have the fancier calculators, it looks nicer. If not, you're going to have to look at a trial to use it. But I'm going to put x equals 1 in this case. Next number is 13. And then I'm going to plug into the equation, which is 2x plus 1. 2x plus 1. Press enter. And that gives me 195. So your calculator this whole time could have done summations. If you have a fancy one. If you have an unfancy one, you're going to have to do it the long way. But if you have a fancy one, you could kind of just use that to your advantage. Okay, so 195. Here, this one would probably be quicker for me to just do in my head here. And then there's quick formulas for a geometric one. I'll explain that in class. Either way, 3 to the 0 power is 2, 3 to the 1 power is 3, so that's 6. 18, 18 times 3, 8, 16, 24, carry the 2, 4, 54, 1, 62. And then just add that all together. 10, 22, carry the 1. 12, 13, carry the 1, 2. So 232 is the answer there. So you can always just expand it. Now here, you're going to be like, yo, infinity. I can't do infinity. Plus your calculator can't do infinity. So what are we going to do here? For this one, when we have infinity, we need to know the equation, which is a1 r minus 1. So it has to be a geometric sequence. So this is a1 and this is r. Very important though, this only works if r is in between -1 and 1. So the absolute value of r has to be between -1 and 1, or less than 1, you can think of it. In this case, this is 2. Because it's 2, there's no sum. Or what the real word would be is divergent. So this has no sum / this is divergent. But here, it is less than 1. So we're going to use the equation that's wrote up here for this. A1 is always the first term, and r is the thing that's getting multiplied. So it's going to be 12 over 2/3 minus 1. I'm sorry, I think I messed up the equation. It's 1 minus r, not r minus 1. Actually, you know what? Let's be honest with myself. Let's check what it is. Sum of infinite geometric sequence, because I forgot. It is 1 minus r. I'll make sure the formula sheet is correct. 1 minus r, which over here is 1 minus r. In this case, the r is 2 over 3. So 12 over 1 over 3, which you could put that in your calculator or flip the fraction or whatever you want to do, but that's going to be 36. Okay. So infinite series, got to use the formula. Okay, for this one, I got to do stem and leaf plots. So stem and leaf plots, remember, we want to put it in order. So here would be the tens place, and here's be the ones place. So let's do it. Here it's a 55. Do I see any other 50s? No. 60s, I see a 63. That's it. 70s, I see a 73. That's it. 80s, I see a 85, 87, 86. Okay. 85, 87, 86, so 5, 6, 7. For 90s, we'll have 91, 94, 94, 91, 93, 97, 97. So let me double line this so I can see it a little bit clearer. So 2 91s, 2 90s, so 91. 93 I took care of. A 94, 94. And a 97, 97. 94, 94, 97, 97. Yep. And then the last one is 100. So we put a 10 in the tens place, and it's just 0. So that's 100. Okay. Now, I could do mean, median, mode, and I'm sure you know mean, median, mode by adding it all and dividing. But let me show you how you can use your calculator. So in this one, you want to go to second stat to make a list. Now it says math, but I don't want math. I don't want L1. So I'm going to click just stat in order to get the list. I'm going to click edit. Now you see how this is L1, L2 on top? We're going to put it in the numbers for their stats. So we have 91, 63, 94. Instead of bouncing back and forth, let me just do it like this. There you go. Let me go back to stats so I can do it. So we're at 91, 94. Let's do 85. 94. If it's tiny right now, don't worry, I'll fix it afterwards. 91. 87. 93. 93. Let me just make sure I cross. 93. 86. 97. 73. 97. 55, 100. 14 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So I just put that on the calculator. Now, what's the purpose of putting it on the calculator, right? Especially in this list form or whatever. Okay. Like, what's the usefulness of this? Well, now I can click second quit. Now, if I go to second list, there's some option called math. And in the math, you might see something that's useful, like the mean. So I'm going to click the mean, and then click second list again, and I'm going to put L1 in there. If you remember, this is kind of how we use the matrices in our calculator. And look at that. If I click enter, I get the mean, 86.14. So the answer is 86.14. Of course, you could add all the things and divide it yourself, but still. And I could do the same thing. Second list, we're going to get the median of L1, and that's 91. Now let's just check that real quick. 5, 5, 3, 3, 3, 3, 5, 5, 6, 4, 7, 3, and then these two are the middle, so between 91 and 91 is 91. The mode could be multiple things. So 91 happens twice, 94 happens twice, and 97 happens twice. So all of these are mode. The range is the biggest minus smallest, so 100 minus 55 is 45. Now the box and whisker plot. In order to make a box and whisker plot, you need the min, the max, Q1, Q3, and the middle, aka the median. We already did the median, which is 91. We already did the min, which is 55. Not that we already did it, but it's really easy. And the max is 100. In order to find the quarters, we're going to take the top half and the bottom half. Since the half is technically in between 91 and 91, this is in part of the top half. So go here, go here, go here. So we need something, wait, 1, 2, 3, 1, 2, 3. So this is the top half or the top quarter. So that's 94. And then over here, we're going to go bottom half. So here, 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 here. So this is the last one, which is 85. Okay. For this one, make your number line pretty clear. Since I go from 55 to 100, so I'll go 50, 60, 70, 80, 90, 100. So 55, I'm going to have a dot here. 85, I'm going to have a dot here. 91 here. 94 here. And 100 here. The outside parts are the whiskers. The inside parts are the boxes. That's your box and whisker plot. Okay, evaluate. You could evaluate this by hand, which is 10 exclamation point over 10 minus 7 exclamation point, 7 exclamation point, which is going to be 10 times 9 times 8 times 7 exclamation point, over, remember this is the same thing as 3 exclamation point, 3 times 2 times 1 times 7 exclamation point. But wait a second, 7 and 7 are the same, so we could cross those out. And then 3 times 2, I could reduce the 3 and the 9 to a 3 and a 1. And I could reduce this a 2 to a 3 to a 4 and a 1. So then all I'm left with is 10 times 3 times 4, which is 120. That's useful, but we even have an easier way. Let's go back to the calculator. I'll clear the screen. In math, we have probability. So we go NCR. If you have an older version, make sure you put the first number first. So 10 and 7, hey, 120. That makes my life easier. For P, we could do the same thing. 10 exclamation point over 10 minus 3, or 10 minus 7 exclamation point, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 exclamation point, all over 3 exclamation point, cross that out. That's a pain in the butt to multiply, so what I'm going to do is just use my calculator. 10, math, probability, I want PR, so 2, 7 equals 604,000, 604, 800. Okay, so use your calculator to your advantage. Mr. Toll's picking an outfit. He has 10 shirts, 7 pants, 3 shoes. So you just do 10 times 7 times 3, which is 210. This is a counting principle because you have different categories. How many ways can you order the word math? Well, there's 4 letters, so 4 exclamation points, 4 times 3 times 2 times 1, which, by the way, in math, you also have an exclamation point button. So option 4 here. Make sure to put the number first. So 4 exclamation point, which is 24. Here, banana, the difference is you have 1, 2, 3, 4, 5, 6 numbers on top, but because you have some repeats, like 3 A's and 2 B's, you need to do 3 exclamation point on bottom, 2 exclamation point on bottom. You could also put this in your calculator, 6 times 5 times 4 times 3 times 2 times 1, over 3 times 2 times 1 times 2 times 1, cross out the 2's, cross out the 1's, 3 and 2, you could cross out the 6, so 5 times 4 times 3, which is 12 times 5, 60. Okay. 100-meter dash, there are 8 racers, gold, silver, bronze. Since these are particular about who goes first or last, so 8P3. So 8P3. So it's going to be 8 exclamation point over 8 minus 3 exclamation point. But to make my life easier, 8 math probability PER, so option 2, 3, enter 336. RK White Chelsea needs to fill 2 math positions out of 10. So 10, choose 2. So 10 exclamation point over 10 minus 2 exclamation point over 2 exclamation point, which is 10, 9 divided by 2 is 5, 45. With a party of 100 people, everyone shook hands with each other. How many handshakes are there? With that in mind, since it's 100 people, and it doesn't matter. Does it matter? No, it doesn't matter who shakes with who, so choose 2. Because every person is only 2 handshakes each, so 100 times 99 divided by 2 is 4550. Actually, let's just check real quick. 100 math probability, which is option 3, 2. 4950, my bad. So 4950. Okay, because it's not particular if I shake your hand or you shake my hand, it's the same thing, so we use C. We're not particular about who's shaking whose hand. Okay, rolling a single die, what's the probability? For a single die getting bigger than 3, there are 3 options, 4, 5, 6, so 3 in total over 6, or 3 winning options over 6 in total, which is 1 over 2. The probability of getting odd, well, wait a second, there's 3 odd numbers over 6 in total, so that's 1 over 2 again. The probability of getting less than 7. Well, that's 6 of them are less than 7 out of 6 in total. So we say that's 100%. So guaranteed. For rolling 2 dice, what's the probability of sum being 5? So first off, what is the total amount of 2 dice? 6 times 6 means you have 36 options in total. So the sum being 5, so that's 1 plus 4. That's 4 plus 1. That's 3 plus 2. That's 2 plus 3. There's no other way to get 5, so that's going to be 4 out of 36. So 4 out of 36, we could reduce that to 1 over 9. Rolling a double, so that's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So 6 doubles out of 36 total possibilities, so 1 over 6. At least 1 die is 3, so that's 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then you have it if the second die is 3. So don't doubt I'm going to do 6 over 36 as one of the multiple choice options. 1, 3, 2, 3. We already counted 3, 3, so we can't count that twice. 4, 3, 5, 3, 6, 3. So in this case, there's 11 out of 36. No doubt, now I'm going to put the fake answer 12 over 36, which is 1/3, because you forgot that you can't double count 33 or 33. And no doubt, I'm just going to put 6 over 36, which is 1/6, because no doubt you forgot the second die. I'm going to put those fake answers, so don't get tricked by those. In the bag, you have 10 marbles. There's 4 blue, 3 red, 3 green. What's the probability of picking a blue? So 4 over 10, which reduces to 2 over 5. What's the probability of picking red then blue? So that's 3 over 10. Then I'm picking a blue. There's no replacement. So there's 1 less bag marble. So there's still 4 blues, but in 9 slots. So 3 times 4 is 12 over 100, which you reduce to 6 over 50, which you could reduce to 3 over 25. Please don't get fooled. I will put a situation where you do 3 over 10 times 4 over 10. Wait a second. I did that math wrong. I just realized. And again, I apologize because I've just been doing math for like an hour and a half. I did the algebra ones here, so if I make a mistake, forgive me. All right, 12 over 90, which is going to be, take out a 3, 4 over 30, take out a 2, which is going to be a 2 over 15. That's actually more correct. Yeah, don't be fooled that I just fooled myself, 12 or 100. Since you removed a marble, you should have one less. So it should be a 9, not a 10. P of white, if you look at the bag, there's no white marbles, so 0%. And then green, then I put it back in the bag, then red. So there's 3 green and 3 red. So 3 over 10 for the green. Then I put the bag back, so there's still 10 in total, and then another 3. So 9 out of 100. Can't simplify that. Let's see how much more I got. Oh my God, is that it? Was that the last IC you had with statistics? Oh, I don't have the latest test. I'm sorry. I don't have the latest test we just took because not everyone took it at the time when I made this for final review. So use this to your advantage, guys. I hope the calculator stuff helps. I know it's a long video, but, deal with it. Have a wonderful day. Good luck on your tests. Good luck on your final, and have a wonderful summer.